Welcome to Data Protection Gumbo. This is episode 15, and I am your host, Demetrius Malbro. Please follow me on Twitter @dmalbro, and also connect with me on LinkedIn. And please consider joining my LinkedIn group, Backup and Recovery Professionals, which currently has close to 17,500 professional members worldwide. And today on Data Protection Gumbo, I have the pleasure of speaking with Doug Soltesz about OpenStack Swift. Doug is currently a senior product manager at SwiftStack and has over 15 years of experience working in IT. And prior to joining SwiftStack, Doug was VP of IT at Bud Van Lines. Doug has been recognized and received innovation awards in the areas of green initiatives, virtualization, disaster readiness, and workflow consolidation. Prior to Bud Van Lines, Doug was president of NetTech Solutions, a systems integrator servicing the New York City metro area. So, without further ado, here is the interview with Doug Soltesz. Welcome to the Gumbo, Doug. How are you doing today?
Great, Demetrius. Great to be here. Thanks.
All right, let's go ahead and jump right in with the obvious question here. The first one that I have is, what is object storage, and why should I use it as a backup target versus, let's say, a traditional SAN or a NAS filer?
Sure. There's a lot of confusion there because object storage is so new. And to be fair, it's not totally new. I mean, Amazon introduced it back in 2006, but I feel like it's really been making headlines in 2014, 2015, and I hope 2016 is going to be a great year for object storage as well. What really differentiates it is its ability to ingest data at just massive speeds or rates. We kind of refer to it as a fire hose of data. So when you think about your standard system, probably the easiest way I can put this is, if you're an admin and you open up a Windows, share, and you're copying a file to your SAN or your NAS, and it's going to start at the beginning of the file. It's going to go from the start to the finish, and depending on your network speed and on your NAS speed and disk is how quickly it's going to move. So generally you're in Windows and you see it's moving, 30, 40, maybe even 80 megabytes a second. And the difference with object storage is objects are still files. They have metadata and some other neat characteristics of it, but they're going to get broken up into little pieces. So now imagine you've got that same 1 gig file you're moving, and instead of moving the whole file from start to finish, it's broken into 10 chunks, and each of them are simultaneously uploaded to the object storage system. And so while one connection may not be as quick, so I may not on each of those pieces be hitting, let's call it 80 megabytes a second, but in each one I might be hitting 50 megabytes a second. And 50 times 10 simultaneous streams means I can, easily saturate 10 gig pipes. And right. So when it applies to a backup system, backup systems are all about moving massive amount of data quickly into a system and out of a system. And that's really what object storage is geared for, besides a ton of other attributes like the durability of data. Not in a lot of SAN and NASs, the traditional ones, you've got your RAID groups, and they're going to be put together in some sort of a stripe. And so that means generally you can lose a disk or two disks and then you're hosed. And when I say hosed, I mean all of your data is gone. And we see a lot of next generation systems out there that are scale out SAN or NAS, but even they kind of limit you to a single rack or a very small data center. When you start talking about object storage, you start talking about things on a much grander scale. I can lose many nodes. I can have them down for a prolonged period of time. I can lose an entire rack. I can lose multiple data center. In fact, we've had clients that have had bad shipments of disk where a number of them failed. 20% of the disk have failed in a certain region or data center at a certain point in time, and they've had absolutely no data loss. Now, to that point, that's what makes this so good for a backup target. What object storage isn't good for is something like running your databases on or your VMs on. So it's not a SAN or NAS replacement all around. It just, when we're talking about backup storage, it's a great solution.
Wow, fantastic. And I know, so in 2015, there were a ton of acquisitions. So I'll deem that the year of acquisitions, right? We have Dell and EMC, being acquired and merging together. And even there was one that was even more interesting. How about IBM acquiring the Weather Channel? Did you hear about that one?
No, I didn't hear about them acquiring the Weather Channel.
Well, yeah, it was kind of interesting to me. Now, they acquired the Weather Channel, and they acquired everything except the TV portion, because what does IBM need with television, right? But I sat back and I thought about that, but IBM acquired Weather Channel for the access to the 3 billion weather forecast reference points. So they were after the data.
Right.
And they also have access to more than 40 million smartphones, about 50,000 airplane flights per day, and all of that is serving 65 billion unique accesses on weather a day. So
yeah,
that's
a
Internet
ton of
things, right. IoT sensors. So and IBM is going to use that data so they can teach Watson. So that's the supercomputer that they had, I think, on Jeopardy at one point. So it's their artificial intelligence cognitive supercomputer, which is some cool stuff. And they are going to teach it and allow it to ingest this information at a very high volume of data. So would you say that this is a perfect use case of unstructured data for OpenStack Swift?
Yeah, so it definitely is. So IBM is a large contributor to OpenStack Swift. SwiftStack is the leading contributor to OpenStack Swift. And when you look at the Internet of Things, the reason it ties so well into object storage or cloud storage is you want to have your storage close to where it's being produced. But in current systems, like in SAN and NAS's, you've got all these different namespaces. So if you've got a SAN at every single different site, how do you get all that data, synced up, replicated together? When you work with cloud storage, the easy thing is these cloud APIs. So the major two are S3 and Swift. And what they're going to allow is for any sensor or phone anywhere talking HTTP, so a very easy common web language, to send data in or pull it out of this cloud structure, this object storage system. And it gets even more powerful from that because in its native format, sitting in those object storage systems, it's now accessible by a system like Watson or Hadoop or Apache Spark for these big data systems. We see a ton of people backing up data with the intention of possibly restoring it in the future. And my company, SwiftStack, works with a number of companies who are backing up data not for the potential of restoring it in the future, but for asking questions you couldn't have asked before against that data set. And so the reason not to maybe put it on tape is you want it to always be accessible so that when we have some abnormal weather, you can ask, well, is that abnormal weather or does it relate to climate change? And to do that, it can't be you're pulling it back from a tape system. It has to be this heterogeneous system that has endpoints everywhere, that the data can go in anywhere, come out anywhere. What SwiftStack calls kind of active, meaning that all of your nodes can ingest, egest data with the same namespace simultaneously.
Wow. Okay, so you mentioned the magic word here, tape. So let's go ahead and talk about tape a little bit.
Sure.
I love to acquire information just about all different types of things here. And several months ago, Linear Tape opened, aka LTO, which I think it consists of HP, IBM, and Quantum, kind of a consortium of all three. And it's also the world's most popular tape format. And they just released their next generation, which is LTO 7. And I think it's available now, which is capable of holding 6 terabyte raw and also 15 terabyte compressed. Also, it can reach speeds of 300 megabytes per second raw and 750 megabyte per second compressed. So tape is definitely it's gaining some speed, some momentum, able to store more, and also it's increasing in capacity and performance. On this roadmap, I think the roadmap goes to LTO 11, which I don't know when that'll happen, but does SwiftStack and cloud storage eliminate the need for tape-based backups?
So I don't think so. I certainly think tape has a strong future. And again, we work with IBM a bunch. IBM is again in that consortium of tapes. So one of the main ways that object storage works well with tape-based systems is that, to your point, the bigger the tape gets, the faster you have to be able to feed it data or accept data from that tape system. The worst thing you can do in a tape system or a tape drive is to let that buffer run out. So if my drive runs out of stuff to write, it has to stop, let that buffer fill back up, and then it needs to, seek back and forward. And so we've all heard this on older tape drives, or maybe using, the old built-in Microsoft tape software storage system, where the drive is going and it's seeking back and forth, and you're not getting that continuous stream of data. So the great thing about SwiftStack and cloud storage is that it's going to be able to feed a tape drive the data it needs at the speed it needs as they move forward. Tapes are great because when you put them on a shelf, they consume no power. The problem with the tape is, going back to that Watson conversation, is how do I access that data now? I don't want to have to pull it back from the shelf. So the augmentation of SwiftStack working with a tape system is really strong in that I want to keep a copy, maybe erasure coded, on spinning disk all the time. So if I need the data, I have it. But I also know that in the case of a complete disaster, I can access that tape. I also know that I can have a lower amount of durability, and so that saves me money in both, heating, cooling, energy on my spinning disk, knowing that I have it on a tape-based system. And again, major companies like Quantum and IBM are contributing to hopefully bring tape into an object storage system where you give an object to the system and you tell it, I want to keep 1 copy on tape and 2 on disk, or 2 on tape and 1 on disk. And by the way, the 1 on disk, I want it to be erasure coded. Erasure coding is very similar to like rating, right? Where I'm going to separate the data into data pieces and parity pieces. So I think tape has a strong future. I think it has a stronger future when coupled with object storage, especially from the point of view of, we've worked with companies today who have massive tape libraries. And when you talk about media entertainment, that tape-based data does not lose value with age. At the company I was at previously, data lost value with age. Right. And when a lot of industries today, data does not lose value with age. And so what they needed to do, and they've done this multiple times, is maybe every 2 LTO generations, they pull back all their old tapes, they pull that data in, and they recode it to the newer generation of tape. Well, that's a massive effort, and it's still an effort that they want to do, but it's simpler with object storage. If all of your data is on object storage, when the next generation of tape comes out, you buy those drives, you buy those tapes, and you archive everything to them because you had it running on spinning disk, and you just have shredded or eliminated those old tapes. So it makes that process much faster, much more seamless.
Okay, great. And something that's complementary, or
yes,
what I've seen in 2015 was, I guess, the rise of purpose-built backup appliances, or PBBA, right? So we have a ton of acronyms in our industry. So PBBAs, they are definitely gaining in popularity. And is SwiftStack a PBBA replacement, or is there a synergy there?
I think, once again, just like tape, I think there's a strong synergy there. The reason that, if I was an admin today, the reason I want a PBBA, and you've had a number of them on your show, in fact, more and more are coming out every day, but, you previously had on the guys from Infrascale, and then, of course, Dell's got their DL series now.
Right.
Rubrik is one that we work with a ton. The whole premise is that most of the time when I need to restore my data, it's probably less than 5 days old. In fact, probably 90%. In fact, I think Brian from Activio said that most data is 90% of restores are under 5 days old. And so when I want some small amount or purpose amount of data back very quickly, a PBBA shines, because going back to what object storage is good at, it's a fire hose. So if you get a massive virus that encrypts your entire system, then you know what? Object storage is the best way to bring that whole thing back. But if you just want a single file or 2 for a user, you want something that's purpose-built. You want it to run against, solid-state disk. But the cost is going to go up dramatically there. And what you don't want to do is try to keep a year on those PBBAs. So I see a huge synergy. I know that you can build your own with, like, say, Commvault, where you build a system, you put in solid-state disk, and then you have an HSM or some sort of tiering policy where you tell it, my first stop is on this PBBA. I'm only going to keep a week or 2 weeks worth of backups there. By the way, every day it's also tiering off to object. In object, maybe I don't have it dedupe, maybe I have full incrementals. I maybe do a different structure of the data because I have more space and I want the ability to restore in other realms. But I see the synergy being the best for any admin that wants a very low RTO, RPO, and to bring that cost to the absolute minimum. By the PBBA for that RPO, RTO, and by object storage, SwiftStack for bringing that cost to the absolute minimum, and for the protection of multi-region, backup capability, replication support.
Right. And definitely cost is definitely a driver in our industry, especially backup and recovery, and i.e. the reason why cloud is really gaining some steam as well. So also a lot of backup providers are adding cloud to their products, as we know. And, what makes cloud APIs different or better than, let's say, CIFS or NFS for disaster recovery, Doug?
Sure. Oh, that's a great question. So one of the main things is the ease of use. So cloud APIs are meant to work over HTTP. And so if you've ever tried to use CIFS or NFS across, latent lines or multiple data centers or VPN links or over the internet or something, it's just not going to work right. So the cloud APIs, Swift and S3, are written to optimize that ease of use. The other thing that administrators like is that these object storage APIs are built multi-tenant. And so each user has a username password or a username signature or a key value. And that makes it extremely simple to operate. So right now when you think about Amazon Cloud or Google Cloud or any of them, you don't worry about where your data is. It's in multiple regions. You just have a web address and you give it a username password and you point your backup system at it and you get your data back. And so that makes your job much easier as an admin because you're not worrying about replication. You're not worrying about when you do a DR scenario, you don't have to tell one database or master server or whatever, net backup or the system wants to call it on the other side how to get at that storage in a different location. It's one location that stretches everywhere, and unlike a SAN or a NAS or a CIFS protocol, it's not a share that's assigned to a system. It's multi-tenant, meaning you can have multiple divisions in there, full security. Nobody can see anybody else's data. They can share if they want. So it's definitely a next generation protocol that really works for backups.
Okay, cool. And object storage is, I guess, still fairly a new technology. I guess what would you say is, the most misunderstood part of this technology, Doug?
So the thing I get asked about or people get confused about all the time is this term eventual consistency. And I think even Amazon has a hard time letting people understand what it is. So the misconception is that I need something that's strongly consistent. And so strong consistent is your traditional NAS or SAN. You write a file and it's you type dir or ls and it's immediately there. And with object storage, when you give a file to an object storage system, be it Amazon or SwiftStack, it's immediately available. It may not be immediately available in all of your different regions. There's a background replication that's going to be happening there, but that's really no different than your current SAN or NAS. So if your current SAN or NAS, if you give a NAS a file and you have a separate site, well, your NAS has to take a snapshot, and then it has to replicate it to the other site, and that full replication has to happen before it's available. And so that is what you would consider eventually consistent. It's not consistent across all the sites at the same time. And so for some reason, there's this misnomer that if I give it data, I may not be able to get it immediately, I may not be able to this or that. And the truth is, if you give an object storage system a file, you can immediately ask for it back and get it. If you do a dir or an ls and you try to list that file out, there may be a period of time before it shows up in the directory listing structure. That's completely true. And if you try to access it from another site, well, because of network links, it may not actually be in the other site yet. However, most object storage systems, especially SwiftStack, will be able to pull that file immediately across, or that object immediately across, which in a lot of ways makes it superior to a normal SAN or NAS, in that they don't even know the file exists until that snapshot is complete and fully replicated to the other side. So it's a real neat mix between asynchronous and synchronous transports and systems. Again, what that doesn't work for is never run a database across, object storage system.
Right.
A database or a VM makes a write, and it expects it to be extremely low latent and immediately available across anywhere it can see it. So again, you got to do the right use cases. Backup's a great one. Again, all that data that the Weather Channel has is another great one. Any unstructured data is a great use case, and eventual consistency just adds to the reduced complexity of the system. It's something to embrace, not to be afraid of.
Okay, cool. You said a lot of interesting things in that one last answer there. And one thing that popped in my mind, I was thinking about Superman and, how object storage can kind of really swoop in and save the day. I'm really thinking that kryptonite for a backup system would be millions of small files. So,
Yes.
Backup systems just have lots and lots of issues of trying to write and backup and even restore, especially restoring, millions and millions of small files. I have tons of stories that I can share with you about problems with just millions of small files. So I don't think object storage is going to have that problem.
No, object storage is built completely around that problem. So, going back to the concurrent connections,
okay.
Normally when you're copying a ton of small files, and going back to my Windows example, it does one after the other after the other. And if you did that with object storage, you'd be hating life, because object storage is more latent than your normal storage systems. The difference in object storage is what you'd think of as a parallel copy. If you have 1 million small files, then move 1,000, 100,000 of them simultaneously. And, we have people easily that fill 10 gig, 40 gig pipes
okay.
with small file movement. Again, provided that the backup or the software is engineered around it. But that's one of my key jobs here at SwiftStack is, being an object storage evangelist, talking to developers at a number of the major backup programs and teaching them how to leverage the APIs to get the maximum benefit out of their system.
Great, fantastic. And also, I guess when backing up data with cloud storage, how is it, how is the data protected? And I also see lots of 5 nines or 9 nines or 11 nines, and it's like, how many nines do we need here? Can you shed some light on all of these nines?
Yeah, one of the things that people ask all the time is they go, well, I've got my NetApp or my other system and it's using a RAID 5 or RAID 6 and whatever, it's got 5 nines, and SwiftStack or Amazon or Google is making these claims of 11 nines.
Right.
And yet when I look at it, it kind of seems like erasure coding or replicas is just that same old RAID technology rebranded with a sexier name. How on earth do you get more data durability? So that's the nines we're talking about out of this. And the answer is that every single object is rated or erasure coded on its own. So generally when you deal with a system, a traditional system, what they're going to do is they're going to take 10 disk or 3 disk and break it into a RAID group and then stripe across them. And when you put data in, it goes across the entire SAN, the entire NAS. When you do object storage, if I do some sort of erasure coding, like I say, I want 10 data pieces and 5 parity pieces, that object gets broken into 15 pieces and it's put in the system as unique as possible. And it's on individual disk. And so it's almost like every single object has its own unique RAID system, which means that in a traditional, RAID system, it doesn't matter if I have 200 disk. If I've got a RAID 6, if I lose the wrong 3 disk, I will be down and I'll lose all my storage. In an object storage system, if you lose those same wrong 3 disk, like you set your erasure coding really low, you will lose some small amount of data, but you won't lose all of your data. And so if you go to any durability calculator and you put in either your replica scheme or your erasure coding scheme, it's going to compensate that object storage calculates its RAID differently than traditional systems, which is going to be able to give you this both higher level of availability, assuming you have multiple sites, and much higher level of durability than you would see on a traditional system. And when we're talking about backups, I think that's probably the key focus is I want my data to be extremely durable. I mean, that's why sometimes you make 2 copies of it on tape. That's your last stop in case something dramatic happens to your company. And so as much as I can eliminate any single point of failure, that's what I want to do. And object storage is the ultimate in scale-out systems. Most of the components are shared nothing architecture, meaning you can bring them up and down without, losing anything.
Right.
Most of them scale linearly, which means as you add more disk or nodes, you bring up more capacity. And again, because of eventual consistency and as unique as possible data placement, it's not like some of these other scale-out NASs you see where you can lose a node or 2 because they're limited to a single region or data center. You can lose entire racks. You can lose entire data centers. And so it does make it far more protective of your data. And I think that's ultimately what everybody wants.
Wow, fantastic. So let's do one more use case, and I think we'll be at the end of our segment here.
Sure.
One thing that I've also been following as well is this kind of captivates me a little bit here. You're talking DNA and genome sequencing, and I read about they finally decreased the price where you can get your human genome sequenced for you for about $1,000 using these high-powered HiSeq X10 systems. I think the company is
Illumina.
Illumina, right? And they generate tons and tons and tons of data and petabytes and terabytes of data just for sequencing data in a couple of days, and you can actually have that information and you can use it for your family tree or maybe something else. But what do you think about that? Is SwiftStack I guess a great product to store unstructured data such as genomic data?
Oh, sure. I work with these companies all the time. Again, they've got a fire hose of data coming out of those machines. Those machines are spitting out extremely small files, back to your point about small files.
Okay.
And then they go to an HPC cluster where not only did all those small files have to go in, but now they have to be, back to that fire hose analogy, pulled very rapidly. When they're pulled, they're then analyzed so that they can reconstruct your genome. And then that results in a pretty big file. In fact, most of these files are, 100, 150 gigs for your genome, uncompressed but aligned.
Wow. And
so then that gets compressed down and distributed out. Every step of the way, object storage makes absolute sense. We've replaced a number of systems because a number of traditional systems out there just absolutely cannot handle that fire hose of data. They also can't handle all those small files. They can't feed an HPC cluster fast enough. They don't have the cost vector factor. And at the end of the day, the one good thing they might be good at is holding that one big file, but they don't have the cost benefits of SwiftStack and object storage. They also don't have what we call a neat function I haven't talked about before, but this thing called middleware, which is the basic ability to insert your own custom code into your object storage system. So imagine you bought a SAN from NetApp and they didn't have compression on it, and you went, gee, I really wish I could write my own compression for NetApp or dedupe or whatever. Now, I know a lot of those features are currently in the product. Okay. But imagine you came up with some next generation thing you wanted to put in. You'd have to write your own system in front of it. Object storage systems, you can write that code, put it in. And so a number of these genome companies store it extremely compressed, but they've written a custom piece of software so that when they ask for it from the object storage system, on the fly, it's being uncompressed. And I know compression sounds simple, but this is a special compression written for and around genomic files. It's all in their code, their compatibility. So at the end of the day, it handles the small files, it handles the fire hose of data, it gives you the cost you need when storing these huge files, and allows you to store the huge files in their compressed state, not just a zip, a WinZip, a RAR file, and to uncompress it into other genomic standard formats on the fly. And so one of your points you had made in a previous show was that Gartner talks about that by 2018, 40% of people will augment their existing backup application, and that in 2016, the year we're in now, snapshot and replication only is going to be a factor. So when you start talking about genomics, they're not using a traditional backup program to back the system up. They're feeding it straight into object storage system, and that is their backup or replication. And then we work with a ton of other companies. So like SolidFire, they're a great, SAN appliance. And if you have all of your VMs running on them, you can definitely run a traditional backup system against it. But you can also just snapshot. And those snapshots and the number of other SAN systems now have the ability to go to cloud. And so you can take that expensive all-flash solution you have, take those snapshots, and back those snapshots up straight to object storage, bypassing some of the traditional backup companies in the process.
Okay.
And you can offload those snapshots to a much cheaper medium than that pure flash appliance. So I definitely think that what the genomics guys do, the media and entertainment companies are doing, and what some of these new high-performance SANs are doing, like a Pure Storage or a SolidFire, really conveys to having object storage on the back end.
Well, fantastic, Doug. Thank you so much for coming on the show. We are out of time. I learned a host of information about object storage and SwiftStack, and we'll have to schedule something for the future because we could probably go on for another 30 or 45 minutes, but let's go ahead and cut this one off. And I really appreciate you taking the time to be on the show on Data Protection Gumbo.
Oh, you got it. I'm a big fan of the show, and I'm glad to come back anytime.
All right. Thanks, Doug. I want to thank you for listening. I welcome your feedback on iTunes and ask that you provide a rating and share with your peers. Please follow me on Twitter at dmalbro and connect with me on LinkedIn. Together, we will be able to add to the innovation of storing data more efficiently and smarter. Have a great week.